In this video, we're going to talk about external connectivity, so how to get routes in and out of the fabric that we've made. So you'll probably want to connect this little section of the network up to another section of the network, and this is going to talk about how do we translate between this fabric where we're doing all this fancy encapsulation to a regular network where we're not doing that. And so that's what we're going to look at in this little section. So if we just kind of look at our diagram real quick, what we're going to be focusing on is this Nexus 5 border gateway here, which we haven't touched hardly at all. And that's been because we're leaving it to do just this one function. So we didn't put any hosts on it. I think technically you can put hosts on it, but most documentation says if you can just leave it to do this one function. That way, if you're troubleshooting, you don't have to be looking at so many things. So that's what we're doing here, is we're just dedicating this Nexus 5 to do one thing. And so what we want to do with it is set it up to be able to route or be a translator for everything on this. The left side is the fabric we've made so far, but then this right side is going to be sort of a typical network. So if you have a tenant and he comes and puts a router in and he needs to connect to everything he has in the data center, we need to provide a way for him to be able to talk to do that for every tenant, each and every tenant. And so here we're going to just do this for both of these. And so what we're going to do is, last video we put some VRFs and we got routing working for the nodes 3 and 4. So we're going to put a VRF on Nexus 5. That way it can learn the routes and pass them on. That's going to be kind of the idea. So as a high level idea, we did this last time. We put a VRF on 3. We put a VRF on 4. Today we're going to put the VRF on 5. Then what we're going to do is, I just made that link a little bit bigger so we could see it. It's one physical link. So on the Nexus, I think it's Ethernet 1.3. This side is Ethernet 1.3. What we're going to do for, say, router for the orange tenant, we're going to make a sub interface. So we're going to, Ethernet 1.3 or 1/3.1000. So it's kind of a router on a stick configuration. So it's going to be a sub interface that kind of goes, it's going to be trunked to the switch. And then say we use VLAN 1000. So Ethernet 1.3.1000. Then we're going to go to the switch, create VLAN 1000, and then put an access interface, or whatever port we have, connecting to the tenant 1 router. That's going to make all that's going to do is give us a layer 2 path. That way we should be able to ping between the tenant 1 router and the sub interface that we made. We're going to obviously stick that sub interface into the VRF just for that tenant. And then once that layer 2 path is set up, we're going to make a BGP session. So that's going to be the control plane for advertising routes back and forth. So that's what we're going to do in this video. And we're going to do the same thing for the blue tenant. So on Nexus 3, we've already got the VRF for the blue. We've already got on Nexus 4 the VRF for the blue. We're going to put a VRF on it today, and also a layer 3 VNI so it can route. And then we're going to do the same thing. We're going to go to that same physical interface, Ethernet 1/3.2000, make a sub interface. And we're going to go create the VLAN on the switch, and then find whatever ports go into the T2 router, put it in that access VLAN. This just makes a layer 2 path from the sub interface on Nexus 5 to the tenant 2 router. Then on that, we're going to set up a BGP connection so it can share routes. And so that way, the border gateway will know about everything over here, and then the tenant 2 router will know about everything over here. So that's what we're going to do. So we can get to the configuration and piece this all together and see how it works. All right, since we're going to be focusing mostly on the border gateway today, maybe I'll make this just a little bit bigger. And let's do one thing on Nexus 3 and Nexus 4 that we'll need to do, which is what we want to do is advertise the switch virtual interfaces we made. So interface VLAN 10 and 20. We want to advertise those into BGP. That way Nexus 5 can learn them. So right now, because Nexus 5 doesn't have anything on it. So what I mean is if we go to it and look at the BGP session, this should be up. The session should be up, but it's not going to be learning anything. Yep, so it's got its connection that we made like in the first video maybe, but it's not getting any prefixes. And it actually is getting them, but it's not saving them, because when it gets a BGP route, let's say that it gets a layer 2 route. So PC1 turns on, Nexus 3 learns the MAC address, Nexus 3 makes a BGP update, sends it to 1 and 2, 1 and 2 send it down everywhere, including 5. But when 5 gets it, it looks at the VNI, which in this case was like 100,010, and then it compares it to its VLANs that it has. And so it's looking for, VN segment 100,010. It does not have that, so therefore it drops the update. And that's good. It's an efficiency mechanism, so that way it doesn't have to store everything that's sent if it doesn't have a host on it. And so it does the same thing for a layer 3 VNI. If we're routing here and this Nexus receives an update, it looks at its VRF table and says, do I have that VNI? If I do, I'll bring the route in. If I don't, I'm just going to drop it because I don't need it. And so that's an efficiency mechanism, but now we're at the point where we actually need to use this for routing. So we want to make the VRF in it so that way when it receives the BGP updates, it'll actually save them and pass them on. So let's go to Nexus 3 and let's look at our BGP configuration right now. And what we want to do is advertise our VLAN 10 into BGP. So we just want to put this right here into it. So let's go into our BGP configuration. And we're going to make a little subsection here. VRF tenant 1, address family, IPv4 unicast. And then here we need to redistribute our directly connected routes. And then I need to make a route map, which I forgot to do. So let's make a route map here. Route map rm permit 10. It's just going to be a route map that allows everything. And then let's go back to where I was at in the VRF. And then I'll try that redistribute command again. Redistribute direct, route map, rm. Okay. And we're going to do the exact same thing for tenant 2. So I want to advertise the 20001. So let's make a sub section in the VRF. VRF tenant 2. Under address family IPv4 unicast, we're going to redistribute our directly connected routes. Which ones? All of them. So let's look at our BGP configuration. So you can see what we added. We just added this. So any directly connected routes we have, which is going to be that interface VLAN 10 and 20, it's going to include them in the BGP updates. What I did here, the push and pop, is I realized I forgot to do something. So this is just saves a bookmark of where I'm at right here. And then if I get out of it, all I need to do to get back in it is put pop, and it pops me right back in. So that's what that was. Just saves a little time. Okay, so this configuration, we want to put exactly the same thing on Nexus 4. So it's templatable configurations. Okay. And what this should do now is it should advertise, put into BGP. We should see something different here. L2 VPN, eVPN. If we look at this, it's going to introduce us a new route type, because so far we've just seen route type 2, which has been sufficient for anything in the fabric. Okay, here's one. Here's a route type 5. And notice it's a 10000, and the prefix is a /24. That's what that encoding right there means. It's telling you the prefix of this, and it's a route type 5. So that's for our orange. We know that just because we remember that, but also more importantly, it's stuck under this section right here. This is the layer 3 VNI for this tenant. In this, we have something similar down here. Layer 3 VNI for the blue tenant, which we use 200,000. And then here's the route type 5. Here's the gateway for it, or the gateway subnet, or the VLAN that it's on, which is a /24. So the 20.0.0.0/24. So that is introducing that into BGP. And as soon as we do our configuration here, we should see the Nexus 5 learn these, and it will pass those on. So let's go to Nexus 5 and create our VRFs, which we don't have, but this is templatable configuration. In fact, what I could do is just go look at my VRFs here. So here's the creation for tenant 1. There's the VNI, route distinguisher auto 2, same thing we did previously, and I'm just going to paste it exactly. And now let's create the layer 3 VNI. So this is similar to what we did kind of last video. Basically, it just all needs to be replicated, or some of this needs to be replicated on Nexus 5. So VLAN 100, VN segment 100,000. Let's go ahead and make VLAN 200 for the other tenant, for the blue tenant. Now let's go to interface VLAN 100. Stick it in the VRF for tenant 1, VRF member. IP forward and no shut. So here's what we have. So this is the routing layer 3 interface for tenant 1. Now let's do the same thing for tenant 2. Interface VLAN 200, VRF member, tenant 2, IP forward, no shut. Okay, let's look at our NVE interface, because we need to do what we did last time here. We need to interface NVE1, and we need to do the member VNI 100,000 associate VRF that authorizes it to be used process routing for that tenant. And we also need to do this for the blue tenant 200,000. Now we haven't touched this NVE interface in a long time, so this is pretty skimpy compared to what we have on this one. Now, but on Nexus 5, we don't need to put stuff like this because it doesn't have hosts on it. But we do need to put the source interface, because otherwise the tunnel's not going to be complete here. So I'm going to paste that source interface. And this, again, this kind of helps it know how to encapsulate the packets. So if Nexus 3 needs to send something here, what's the outer header going to be? It's going to be this IP address, loopback 0. And this is all from probably our initial video. It tells what that does. Okay, so I think our NVE interface looks okay now. Okay, and let's show interface. So make sure it's up. Oh, it's NVE no shut. Okay. All right, so now let's work on the layer 2 connection that we want to put right here between Nexus 5 and these routers here. So on Nexus 5, let me go to the wiring diagram for this. Here we go. So on Ethernet 1.3, first thing I'm going to do is go to the actual interface and just type no switch port. That way it makes it a routed port. And now let's go to interface E13 dot, so we'll use 1000. So this is just, kind of sub-interface router on a stick type configuration. That's kind of common maybe for a small office or something. We're just using one link to trunk lots of VLANs, but we're kind of using it in a routed fashion. So in cap, you got to specify what VLAN you want to use. Okay, now let's put it in the tenant VRF. VRF member tenant 1, because we need to link these routing tables together. This sub interface needs to have access to the VRF we created here, just for this tenant, because a VRF is the a carved off routing table. We need to make sure we put this interface in the routing table just for the orange tenant. After we put it in the VRF, we can put an IP address on there. It's going to use 5 for this nexus. And no shut. So while I'm here, I'm going to go ahead and do the other interface for the blue tenant, E13. So same physical interface, but a different sub interface here. So encapsulation dot 2000. Here I'm going to put it VRF member tenant 2. Then we can give it an IP address 10.255.25.5. And let me make sure I no shutted the main interface. Okay. So we've got sub interfaces and linked them to VLANs 1000 and 2000. So on our switch, this is a very simple configuration on the switch. I think I already pre-configured it, but to save time, but I'll just show you. So let's look at interface gig 00, which is facing the nexus. So it's a trunk, and it only has these 2 VLANs allowed on it. That's all we need. And then we need to make sure the VLANs exist. Show VLAN. And there's 1000, and there's 2000. So they exist, and then we need to make sure they're set on the outgoing interface here, which would be gig 01. So there's your to tenant router 1 access 1000, and then gig 02 would be going to tenant router 2. It's an access port. So this switch is just doing transit connectivity. It's just providing a path. But the VLAN is kind of this here, which is passing multiple VLANs. This switch is just logically splitting that VLAN out to the right place. So that's simple configuration. So let's look at tenant router 1. I've done nothing on tenant router 1 except for put IP addresses on there. So if we look at gig 1, there is the IP I put on there. And so we should, at this point, we should be able to ping the Nexus 1/3.1000. Oh, I typed the wrong IP there. There we go. Okay, so our layer 2 path for orange is good, and we should be able to do this same thing here. Gig 1 has this IP address, and ping 10.255.25.5. Okay, so we have layer 2 connectivity here between them, and it's separated off into the right routing tables because of the VRFs on Nexus 5. So now we can go configure a BGP on the border gateway. So let's look at what we have existing. Not a lot, but now we want to make the BGP session to each of these routers. So how we do that is we go into the router BGP section, and then we, kind of like we did a while ago, we carve a little hierarchy section here inside BGP VRF for tenant 1. Then here's where we put the neighbor. 10.255.15.1 I think was the router. Remote AS, we're going to use 6511. This is an eBGP neighbor. We know that because that's a different number than this one. And then we want to make sure we turn on IPv4 unicast because that's the address family we're going to be interested in passing over this BGP connection. Okay, so let's do the exact same thing for tenant 2. Now put the neighbor. Remote AS, I'll use 6522 for this one, the eBGP neighbor. Make sure we have IPv4 unicast turned on. Let's look at our summary BGP. And so this is what we added. And so what this is saying is, so here's my main BGP configuration. So when Nexus wants to make a connection, establish an adjacency with 150.111, it uses the global table. When it tries to establish a connection with this one, it uses the global table. This is why it's hierarchical, kind of. Notice the neighbor statement is under the VRF. So when Nexus wants to establish a neighborship with this person, it knows to use this routing table. So this tells BGP, if I want to talk to him, I must use this routing table, not the global table. So it looks confusing at first, but it does make sense if you think about it. Like, there's this IP located? It's under the VRF. Where's this located? It's in the global table. So, this is more underlay here. So next we can configure the tenant routers here. So let's go to router 1. And I think what I'm going to do here is we're going to just sort of simulate a corporate environment. So we'll take this router, and let's just say this is an EIGRP domain. So I'm going to stick, the gig 2 side in EIGRP. Then we'll redistribute. And for here, I'm just going to do OSPF. I'm just doing this just to show you can do whatever. Kind of whatever you want. Okay, so if we look at router 1, let's just make some EIGRP configuration. I'm going to use the named mode, the new named mode, newish. Address family IPv4 unicast autonomous system 1, and then network I'm just going to put 10.220. Okay, I think that's all I want to do here. So now there's no BGP on this at all. So I'm going to make the session 6511, I think is what we're using. Now here, neighbor. Now this router has no VRFs or anything. The assumption is that this router is completely owned by the orange tenant, so it has no need for VRFs. So neighbor, we're going to put the Nexus IP. And so now, while I'm under BGP, I'm going to go ahead and redistribute my EIGRP routes from Autonomous System 1. I'm going to take those routes from my EIGRP database and put them into the BGP database. So in other words, let's look at the show IP EIGRP topology. So I have this in the EIGRP database, and now I have, by doing redistribute, I've moved it here to the BGP database. So now what that means is it's going to send it over here to the border gateway, and the border gateway is going to send it to Nexus 1 and 2, and it's going to go to 3 and 4. Now what I also have to do is kind of redistribute the other way. So what we've done so far, so we've taken our EIGRP routes and put them in BGP, but I need to also take our BGP routes and put them in EIGRP. So let's go back to EIGRP. And redistribute BGP 6511. I have to give it a metric here. Okay, I think it took that. Okay. And that, so show IP EIGRP topology. And we should see this, I believe, grow here later on. So let's go to the tenant 2 real quick. and just do a quick EIGR OSPF here. Router OSPF 1, network 20, area 0. Okay, and now let's make the BGP session here, 6522. And neighbor 10255, I think 255, remote AS. And then here we're going to redistribute our OSPF process. And now we need to do the reverse. Go into our OSPF and redistribute BGP. Redistribute BGP, autonomous system 6522. And then we do subnets whenever we go into OSPF. Okay, so a lot of this is not related to necessarily VXLAN. It's just, I'm just trying to emulate like a corporate network over here that could, I mean, it could be one router, it could be 100, 1,000. It's just getting the routes from the fabric completely into the, you know, corporate network or another network. Okay, so at this point, routes should be, I believe, going back and forth. Let's go to Nexus 3 and see if we can see what we can see here. Well, let me go to the, let me clear this and let's scroll back up to the cleaner diagram. So let's go to PC 6 and see, can it make sure it can ping the default gateway 10.221. That would just be this interface here. Now, just for fun, let's see if it can ping 10.0.0.10. It can. So it looks like it's working. Let's see. Oh no, it says unreachable. Okay, so destination host unreachable. Okay, let's go to Nexus 3 and let's see if it knows show IP route in the VRF tenant 1. So it does not know about the 10.2 network. Let's see if Nexus 5 is learning it. So if we show IP route VRF tenant 1, so it's not learning it. Let's see if this let's go back to the tenant 1 router. Might probably mess something up there. Okay, show this is just simple IPBGP summary. It's not up. Okay, I typed the wrong IP here. That should be a 5. Now let's check the neighborship. Well, that should be 15.5. I think I just had my finger in the wrong place the first time. 15.5. Okay, so we can ignore the first two. I could take them out, but okay, there we go. This is the one that now it's showing the neighbors up at least, and now it's receiving routes. So show IPBGP, and so we're getting, that's us, and here we're learning the rest of these. So let's go back to PC 6 and rerun that ping. That looks better. Now it's working. Okay, now we should be able to see that on Nexus 3. If I go back and look at the VRF table, There's the 10.2.2.0. Okay, so we do have that working. Let's see if PC3 can ping. Let's see if we can ping from PC3 to the 10 to this 10.2.2.10. So PC3 ping 10.2.2.10. That's working. Awesome. Now let's just check our blue tenant. Let's just go to PC7 here. Let's see if we can ping 20.0.0.40, which is going to be that PC4. Okay, that's working as well. Okay, let's just look at the BGP routing table on some of these routes just to show BGP, L2 VPN, EVPN 10.2.2.0. And what we'll see here. Okay, so this is from Nexus 3. So it knows 2 ways to get there because it's learning it from 1 and 2, and everything's got an equal cost here. There's the next hop. There should be extended community. So this is how the board, you know, when this is our layer 3 VNI, and that's how Nexus 5 knows. Now that Nexus 5 has the VRF, when it receives this route, it looks at this whole thing. Specifically, it looks here. Nexus 5 says, do I have a layer 3 VNI with 100,000? It does, so it saves it this time, and then it passes it on to the routers. So this is a route type 5. So anything we receive, like from the routers, is going to be a route type 5. Let's try it. Let's just try this here. Let's go make a loopback interface, loopback 1000 IP address. Let's do 100.100.100.100/32. And then we probably need to put this in EIGRP. And then network, or is it network 100. So now that it's in EIGRP, it should get passed over. Let's see if we can see this now. See if it shows up over here. 100. Oh, there it is. And it's a route type 5. The prefix is a /32, which we just made. There it is. And it should be able to get there. Let's go to PC1 ping. And there it is. Let's do one or two more just super quick things just to kind of show, and I want to show this efficiency thing. So one thing that it's doing that I can show is if we look at router 1 and we do show IP route, it's getting a lot of host routes, which makes sense because that's, you know, when we look at the prefix information, everything in the fabric routes on kind of host routes, very specific routes. But when we pass those specific routes on to a router, there's just a more efficient way to do it, because what we probably should be passing is the network itself, like the switch virtual interface, which is like a /24, rather than all the hosts in that network. You know, we could either send out 1/24 or 254 or whatever host routes, and they're all going to be routing the same way. So seems inefficient to send these host routes. So because this tenant 1 router, it's learning this already. That's the very first step we did today, I think, was we advertised the VLAN 10 into BGP, and the reason why is so we could have the VLAN 10 come over here to the tenant routers. So what I'm getting at is what we want to do is block the host routes, because we already have the less specific route, so we don't need the host routes. So it's simple to do. We're just going to go to the border gateway, and let's make a prefix list. I'm just going to call it PFL, and we'll say sequence 1,000. Permit 0,0,0,0/0 less than or equal to 32. That's just going to, yeah, I think, let's try that. So we have a prefix list, and now we just need to look at our BGP configuration and apply it. So let's go to BGP here, and this is under our VRF. So I need to go, I think it's under IPv4 unicast. So prefix list, PFL, and then outbound. So we want to use this filter when we advertise routes out to tenant 1. Okay, so let's see if that was enough to do it, or I may need to do a route refresh. So tenant 1, if I just do an up arrow, okay, host routes are still there, so let's do a route refresh. So that's going to be clear BGP, L2 VPN, EVPN, all neighbors soft out. This makes Nexus 5 re-push all of its routes in a clean way, in a soft way. It doesn't hard bounce it. So now if we come up here, okay, I did make that prefix list wrong then. Should be IP prefix list, PFL. Let's deny. Let me put a sequence of 1, just to be the first thing in there. Deny. There we go. Deny greater or equal to 32. So the first one will permit everything else. This one's what denies. Let's look at the prefix list, the whole thing. This is the one that's going to deny any host routes that are greater or equal to 32. This one's going to let everything else pass through. Gets kind of confusing sometimes. But let's try this now. Let's do the route refresh again. And then let's go to the tenant 1 router. And what I'm hoping to see, I'm waiting to see those 32s drop off. So let's refresh this. Okay, that one, they looks like they did drop off there. So because we were learning all the 10.0.0, the only 10.0.0 now is the /24, which is going to that BGP router. So that's just an efficiency thing. We could do that. You typically do that for down here too, but it just cleans the routing table up, makes it a little bit smaller. And again, there's really all you need, I guess. Well, I would put both probably so you don't drop everything. And last thing, let's just do a Wireshark on Nexus 5. I'm going to start one on both interfaces just so we can see the encapsulation that it's doing. But it's going to be similar to what we've seen before. So there's the kind of the left interface, and then the right interface is here. So let's ping from PC1 to the 100, 100, 100 again. That's fine. And then we should be able to see here so they're being split across both links. So there's the request is going one and the reply is coming the other. So we'll just look at the request. So here's the inner header and here's the outer header. It's going from 3 to 5. So it is being encapsulated. And here's that, that update source loopback. That's why we have that. It tells Nexus 3, what's the outer header? Well, it should be 151.5.5. The VXLAN, the VNI, there's the layer 3 VNI. So in other words, whenever 3 sends this to 5, 5 looks at this field here, 100,000, Then it goes through its VRF tables and it asks itself, you know, do I have this? Show run section VRF. It looks through its VRFs and here's a match. It does have it, so then it pulls this. It'll pull this route in. Well, if this was a routing update, in this case, it knows just what VRF table this belongs to. So when this route comes in, it knows this is where to stick it based on that layer 3 VNI, and then it does another. It'll decapsulate it, and it'll do another lookup to wherever this is going. So here's where we're actually headed to. This is the client here, where we're actually going, and so when it sticks it in that VRF, then it does show IP route 100 VRF tenant 1. Then it knows to send it out here, and it doesn't do any encapsulation this way. So that's external routing. I think that's all I kind of wanted to show here. And so we'll just see what happens from here.